Barry has a 67 in bio class. He goes to office hours to get extra help, and he brings up his grade 3 points each time he goes to office hours. Write an equation for his grade. Okay, so first, the easiest thing to find is usually the starting point. And so in this case, it's here. And then the rate of change, when he goes, he brings up his grade 3 points. So it's going to be positive 3. And already I can write my equation. Y equals, it's always the rate of change times x plus starting point. Now, what are the two variables? What are the two things changing? Well, one thing that's changing is his grade, and the other thing is changing is the number of times he goes to office hours. So it's like the number of times he goes to office hours and his grade. Now, which one is the cause and which one's the effect? Like, which one is causing the other one to change? Well, his grade going up is not causing him to go to office hours, right? He goes to office hours, and therefore his grade changes. So it's the independent variable is always the cause, and then the dependent variable is always the effect. So because he's going to office hours, this is how many office hour sessions he goes to, his grade is changing. His grade is going up. Okay, so that's independent and dependent. So what will Barry's grade be after 6 office hour sessions? So let's see, office hour sessions is x, so I'm going to plug in 6 to x. So 3 times 6 is 18. 18 plus 64, we get 82. So 82 is what his grade is after 6 office hour sessions. How many office hour sessions has Barry gone to if he gets his grade up to a 91? Okay, well, we're going to use the same equation, but this time his grade is a 91. So what letter represents his grade? The y. So we're going to plug in 91 to the y. And then we need to solve for x because we're looking for how many office hour sessions, and that's what x is. So first, let's get rid of the 64 on both sides. 91 minus 64 is 27. And then I divide by 3 on both sides, and I get 9 equals x. So it's 9 office hour sessions. And if you ever get confused, like, okay, wait, I got 9, but what is it? 9 what? Well, it's 9 equals x, right? Well, x is office hour sessions, so it has to be 9 office hour sessions. Lucy buys a TV on a payment plan for $900. She has to pay $150 each month. Write an equation for how much she has left to pay. Okay, so starting point, she has to pay $900. Now, rate of change, she has to pay $150 each month. So she's on a payment plan, meaning she owes $900. When she pays $150, that means the amount that she owes, it goes down by $150. So it's going to actually be negative $150, which makes my equation y equals negative 150x plus 900. So what are the two things that are changing here? Well, she's paying each month, so the time is changing. So month is one thing that's changing, and then how much she has left to pay is the other thing that's changing. So which one's independent and dependent? Well, month is time, right? We remember that time is always independent. So this is the months, and this is how much she has left to pay. All right. So y equals negative 150x plus 900. After how many months will Lucy be done paying off the TV? $0 left to pay. Okay, so we want to know how many months. We want to know x. And we know that y, how much she has left to pay, is 0. So we want to know, like, when will she be done? When will y be 0? So we plug in y for 0. And then let's see, I need to get x by itself. I could subtract 900 from both sides. That would make sense, right? And I'm going to do that. Another option is if I wanted to keep everything positive, I could add 150 to both sides. Then I'd have 150x equals 900. So actually kind of the same thing regardless. This way I end up with negatives, which is okay. And then I have negative 150 being multiplied by x, so I'm going to divide by negative 150, divide by negative 150. Negative divided by negative is a positive, so my answer has got to be positive here. And let's see, what's 900 divided by 150? That is 6. And so, after how many months will Lucy be done paying off the TV? After 6 months. Oops, this doesn't have an E. How much will she have left to pay after 2 months? Okay, so x is months, so I'm going to plug into 150 times 2 is 300. And this negative times a positive, it's negative. And then what's negative 300 plus 900? It's the same as 900 minus 300. Well, let's see. So 9 minus 3 is 6. So 900 minus 300 is 600. So, and it's how much will she have left to pay? So it's $600 left. All right, last question. The cost of airing a commercial on television is modeled by the function c equals 110n plus 900, where n is the number of times the commercial is aired and c is the total cost. Based on this model, which statement is true? Okay, before we read this, let's look at this. So this is the equation, and we can see that y equals mx plus b, right? We see there's a variable and a variable. This must be the rate of change, and then this must be the starting point. So n is the number of times the commercial has aired. So it seems like the cost goes up every time it airs on TV, but then even before it airs on TV at all, the cost is 900, right? So like, because you can see like even if n was 0, the number of times it aired on TV, even if that was 0, it would be 110 times 0 would be 0, but the cost would still be 900. So the starting cost is 900 somehow, and then it goes up 110 times every time it airs. So let's look. The commercial costs $0 to produce and $110 per airing up to 900. Well, that doesn't make sense because the starting cost is 900. So it can't cost 0 to produce because that must be the starting cost, so no. The commercial costs $110 to produce and $900 each time it's aired. No, that would be these switched, right? It only costs $110 every time it's aired. That's how much gets added. The commercial costs $900 to produce and $110 each time it's aired. That seems right, right? It costs $900 to produce, that's why that's the starting point. And then every time it's aired, they have to add $110 to its cost. Let's read the last one to make sure. The commercial costs $1,010 to produce and can air an unlimited number of times. No, that doesn't make sense, right? That's just these two numbers added, but that's definitely not right. Okay, should be number 3.